Imagine you're playing a video game and you discover a literal cheat code that skips hours of grinding. That's sort of like index laws in maths. It sounds weird and complicated, but when you truly understand it, it's just so simple. Today, we're destroying this massive myth that exponents are hard. Since the topic I'm about to cover is pretty big, this is gonna be part 1. Part 2 is gonna be released 2 days later on the next maths day. So without further ado, let's begin with part 1 of exponents. Let's go. Let's start off with multiplying powers. Let's say, for example, we have 2 squared times 2 cubed. 2 squared is 2 times 2, and 2 cubed is 2 times 2 times 2. Now, multiplying all these weird 2's can get a bit tedious, so instead, we can simplify this. We see that the base is the exact same. The base is the bigger number over here, not the one on the top right corner, that's the indice. The big number, which in this case is 2, is the same on both sides. So what we can do is that in this special case, we can add the powers together. That is the cubed, which is 3, and the squared, which is 2. 2 plus 3 is 5. So we can just simplify this to 2 to the power of 5. As I've said before, the base must be the same. If we have something like 2 squared plus 3 cubed, we can't use the same trick. Now let's flip the script with dividing. This is the inverse of what we've seen before with multiplying powers. Let's say in this example, we have 5 to the power of 5 divided by 5 to the power of 3. Again, it gets a bit tedious doing 5 times 5 times 5 and so on and so forth. And even if you have memorized, or actually you shouldn't necessarily memorize, but even if you do know what the values are, then it will get a bit tedious with all these weird divisions and stuff. So instead, what we can do is that when we have dividing, and again, when the bases are the same, we can subtract the powers. 5 minus 3 is equal to 2. So we have 5 to the power of 2, which is just 5 squared. 5 times 5, 25. Now for the boss level, power of a power. Let's say we have x squared the whole cube. This sounds and looks really weird, like what's a bracket doing here? But this basically means that anything inside of this bracket is raised to the power of the indice outside the bracket. In here, we multiply. A common mistake that many students make is that in the multiplying law, they add, but they also add in the power law. You shouldn't do this. In here, you have to multiply. Any individual or any separate value or item within this bracket will be individually raised to the power outside of the bracket. Back to our example, x squared the whole cubed. Here, we raise x squared to the power of 3. That means x squared times x squared times x squared. And using our multiplying law, we can see that x squared times x squared is just x to the power of 2 plus 2. That's 4. X to the power of 4 times x to the power of 2. That means x to the power of 4 plus 2, which is x to the power of 6. And we can prove that by looking back, and we see that 2 times 3 is 6. Perfect. So let's do a little quick recap. Multiplying, you gotta add the powers. Dividing, you gotta subtract the powers. And when you've got a power of a power, which includes brackets, you have to raise everything inside of the bracket separately, as in individually, as separate items, to the power. Well, that's about it for today. Thanks for watching. Tomorrow's gonna be Science Day, day 8 of the summer lock-in, and I'll see you there. Goodbye.